So hey everyone, it's me Deepak. So today here we're gonna understand. We will be solving the problem called as alien dictionary. What does this problem is and what is it asked us to do? Let's look into this. Good. So here's the problem statement that is given to us. So what it asks to us. Let's have a look into this. So here's given that let's say for example if I say uh, if we have let's say we land on a alien planet, they don't tell you their alphabet. Means we know that our alphabet is what we use what a b c d e f g s something like that. Means generally we use, means in our English alphabet what's the letter we does have. We have a, then b, then c, then d, then e, then so on, something like that. And then we like something like this, and then x, then y, then z. But over there they are aliens, they are not going to use our standards of communication. Means the way we are talking, the way the alphabets which we are using, they have some different communication language. There are some different standards that they set. And over here this is what they use as their language. Means because our dictionary is different. In our dictionary we have the letters from a to z. If I say you, let's say this thing over here, this is the alien. Let's say I does have a word alien. So alien, and let's say I does have a word dictionary. So over here in our English letter what happens, okay, as you can see over here, I have a, which comes before d. So obviously whatever the word I does have will that is with starting with a should be, and here it is before this d. That's the thing which we does. So let's say for example if I'm saying the word I does have is Deepak. Cool. And let's say the word I does have is let's say for example if I write, let's say defend. So yes, we can see that okay d, this is the same. So obviously there's no differentiating factor over here. E also same over here. E f, okay, there's a difference. So let's check, let me check it. Okay, e comes before f in our English dictionary. So obviously that's why uh, what should be the case over here. That's why the Deepak would be before this particular word defend. I hope you're getting it out. What in general that we do use, but over here in the alien dictionary it has something different. They just give us a dictionary. So our task is what, I need to figure out the alphabet order as well of them. Means over here, let's say I'm taking an example of this. Let's say over here we that is given to us is this. So if I can see over is that this thing, okay. So they will be, what this problem gives us, they will be giving us words, list of words uh, that they will be giving to us. So let's say for example the words which they give us is this let's say baa, baa, and let's say abcd, let's say abca, and let's say cab, cad. So over here these are the words given to us, and from this I need to figure out what's the order that they maintain. We know that in English dictionary the order is a b c d e f g s, something like that it goes. But over here in the dictionary I don't know the order, so I need to figure that out as well. So the thing which is pointed to us is this words, and number of words that is pointed to us. Let's say for example over here is this, and it's shorted in an alien language. Just like over here we are sorted in a human English language, it has been sorted in an alien language. So if you can see, uh, here it's BAA and here's ABCD. If it's, let's say, if it's under the consideration of the human English language, in that case what will we do? Oh, here this will come before this. That means ABCD will come before BAA. Why? Because A comes before B in our English dictionary, as you can see over here. A is coming before B. So that's why uh, this I hope you are getting that the what's the difference over here. So alien dictionary maintains a different kind of orders. So we need to determine the correct order of letters in this alien language based on the given words. If the word is valid, good enough, I'll be returning the string containing the unique letters in lexicographically increasing order as per the new languages rule. So uh, but how could I do this thing? And also there could be many multiple valid orders for a given input. So we need to return any one of them. If any, and let's say there's they have given us the wrong list of words, hint this thing just to manipulate us. So in that case, this could be the case. So in that case, if there is no valid order exists due to conflicting constraints, I need to return an abstract string. So let's look into this. That let's draw on this thing. So this so the intuition will get ignited in a brain. So over here, what is given to us? So we are told the words are already shorted. At least this hint is with us. That those aliens said that informed to us. That means the ordering information, that how it will be getting ordered, that letters are hidden. This information is hidden between these consecutive words. I need to figure that out. Okay, based on this, what's the ordering of the elements, or I could say the letters? If BA is coming before ABCD, then what's the pattern between these two? I need to figure that out. Okay, if B is coming A, so I can say, okay, I can calculate this. Okay, B is coming before A from this. I can say this. So this kind of pattern I need to figure that out. Let's say I'm comparing this BAA and ABCD. What I can see, if I'll be comparing character by character, I can see that if I will be doing B versus A, I'll be iterating for through the entire word. So over here, I can conclude that B comes before A. That denotes okay, this first mismatch according to our English dictionary gives a direct dependency. That means uh, over here B should come before A. So let me write that B has to be before A, something like this. Cool. This is a thing which I come to know from these particular words. Okay. So now let's check for the another two consecutive words. Over here, what is given to us? A B. Okay, let's go character by character. A is here, A is here. Okay, I can't figure that out based on this because both are same. B is here, B is here. Okay, same. C is here, C is here. They both resides at the same level, same position. They are at the same place itself. So there's not any differing character here. D here, A here. In a normal human English language, A comes before D. And here D is, this particular word is before this particular word. That means ABCD is before ABCA. In that case, what it indicates, that D is coming before A. That's why I have placed this in this particular way. So that denotes just, okay, D should come before A. Okay, let me write that. Okay, over here D should come before A, something like this. Cool. Now if I see, now if I'll consider these two consecutive words, A is here and C is here. They are two different characters. So A is coming before C. From these two particular words, I can conclude this thing. So A is coming before C. So let me write that. Okay, over here C is there, and before that A is there. Cool. This can be the possible answer. Okay, there could be various ordering that can be possible. So here, let me consider this two particular word provided to us. So C is here, C is here. Let's go character by character. Same thing. A is here, A is here. Same thing. B is here, D is here. From this, what I can say, okay, B is here and D is here. That means B has to be before D. How I did conclude this? Because cab word, this CAB word is before CAD. CAB is placed before CAD because B has to be placed before D. Okay, that's already there. I already placed that. B is before D. So from this, I can say that okay, this is the ordering. Okay, B has to be before D, and D has to be before A, and A has to be before C. Okay, cool, good. And uh, this is the one of the possible way that I get could be that could be the answer. So if you see that, what's the key point? What's the addition that I'm getting from this is that what's the pattern? Is that once I find the first mismatch, oh yeah, if you can see this thing, these two words under consideration, C is you, C is you, A is you, A is you, B is you, D is you. I find the first mismatch. I will stop then and there itself. That's the differentiating factor for me. There are different characters. So anything after that is irrelevant and must be ignored. Because as you can see over here, D is here. From this, I can't figure out that which word has to be before and which word has to be after the particular pivot index, pivot element. Should both has to be same, that has I need to figure out based on some differentiating factor that has to be there. So easier, I can't say that. The moment I find the mismatch, that is the different characters, so I'll stop then and there itself. There's no need to check further because that's irrelevant and must be ignored because I already figured it out. Okay, why this Deepak what is before defend? I already figured it out. So there's no need to do this thing. So let's say, for example, if I have a words, something like this. If I can say A B C D, or let's say A B. Okay, if I have this word, particular words, so all characters over here, uh, all characters over here, all. See, let's do the traversing to this as well, character by character. A is here, A is here. There's no differentiation between these two characters. There's no mismatch. First mismatch I want. B is here, B is here. It's also a match. C is here. There's nothing to compare. So how can I figure it out? What has to be before, what has to be afterwards from this? So it violates the dictionary rules. So here all characters match, but the first word is longer. So the input is invalid. We immediately return an empty string in this case because I can't figure out the what could be the ordering. How can I figure this out? Because from this I can see AB is there. Okay, this word is before this word. ABCD is before AB, and to differentiate, okay, which character has to be before which, there's nothing to there's no mismatch from that I can get an idea at how and what word a character is placed before what, and that I can't figure that out. Okay, so it violates the our condition. So in this case, what I'll be doing, I'll just simply say return, I'll just simply return an empty string. I don't need to do anything over here. I'll be simply returning an empty string because I don't have any answer, bro. I'm not able to find it. That's a thing that needs to be under the consideration. And over here, as you can see, this is the main part, because if I encounter this, I just not there's no it makes none no, it makes no sense to go further. So this is where many solutions fail. We need to highlight this thing. In that case, I just be just simply returning the an empty string because I'm not able to find any possible answers. So if I can see, while solving this, while going through this problem statement and the dry run, I figured out that okay, some character has to be for something, like that pattern. So B has to be for D, D has to be for A has to be for C. Okay, so what if I can say this is something like a pattern which we usually does in the topological sorting and in the graph algorithms. If I can let me write that. Okay, the pattern which I'm getting I'm getting the intuition from this is topological sort. So can I do that over here? Yes, obviously that's what it denotes. Over here I should go with the topological sort. Why? I already said why. Because over here, let me consider topological sort is what? What does it says? It says that uh, I want a linear ordering of the nodes where there's an edge between u to v such that u points to v and where u has to be before v. And this pattern, let's say, for example, v is some course. Okay, v is some course. Let's say v is an engineering course, computer science engineering. To do that, I should be doing some basic IT course or some schooling on college, school and college. So U is the prerequisite in order to complete this particular course. So in order to figure it out, I should have this thing. U should come before V. That is, I need to complete, I need to look for view before going to v. That's what here also I'm doing. B has to come before D in order to create this thing, in order to insert the words in the dictionary, or and how that aliens are placing their words in the dictionary. So I need to do that stuff. So this is what topological sort does. And I can do that in the two ways, that is BFS or DFS. So if the BFS, okay, topological sort, if I'll be doing it with the BFS, in the DFS is the topology sort, that is a recursive way. And if I'll be using BFS, I can go with Khan's algorithm in order to implement this topological sort kind of stuff over here. But there could be the case that okay, I found the linear ordering, cool, that's fine. But alien is doing this kind of game with us, this kind of manipulation with us. Let's say they are giving something like this. There's one more word under the consideration, apple. So over here, apple, there is cad, that is cad. I need to figure it out, okay, why apple is after cad. Let's check that out. C is here, a is here. The very first character itself is the mismatch, so let's figure it out. Based on this I can say that okay, okay, there's u. Let's say I'm considering c has the u, a has the v. Okay, so u, that is the c, and v, that is the a. So c has to come before a. So let's write that c before a. Okay, c has to be before a. So yeah, cool. I wrote that, okay, c is before a. But wait, a is already there. A has to be before c. I have already determined this thing from this stuff. Then how can at the same time C is before A and A is before C? So I can't move further. I'm in a ambiguity. I don't know. I don't know that what to do in this case. There's a dilemma. So if I got the intention that okay, it's about the topological short or the constant algorithm that I need to implement, and also before that, as I know that I'm gonna use this and why I'm gonna use this, that's also we know. Okay, so just for our ease, that okay, if I'll be considering each character has the node, and in the graph we usually do zero based indexing or a zero based node or one based node. There are random nodes also. Let's say for our ease, this node can be anything, 10, 20, 50, 1000, any value. But let's say for our ease, let's say I'm going with some 0, 1, 2, 3 kind of nodes values that we usually do, so for the ease of our implementation. So let's say uh, what I'm trying to say is this: 0 is a, one is B, two is C, and something like this. If I can, if I want to visualize you that, okay, okay, A is 0, B is 1, C is 2, D is 3, A is 4, something like this, and keep on. I just keep on going from this, and I would say over here X is 23, or Y is 24, Z is 25, or something like this. I can do this thing for ease. Okay, so that's the thing I figured out. Okay, that's the small implementation, but I can tweak it. And what I wanna say that, okay, as I know that, okay, I'm considering this as the node, and I'm gonna use this approach. So let's try to convert this into a nodes, into a graph. So firstly we will be considering this graph, that how will this look. So let's do that. So over here, what does I have? I have nodes over here, that is B, D, A, and C. Okay, when the ordering, I'm just considering this ordering, and this example I haven't included the apple yet. So in that case, how the graph will look like. Okay, so let's say I have a node over here. Let me draw it. Okay, this is what this is, B, B. Okay, which is pointing to whom? Okay, which is pointing to D. So let's create that. Okay, now B is pointing to D. Let's have one more node over here, that is D. Great. Now what others have? A. So okay, let me create a node as well. Okay, firstly, before doing all this thing, let me have all these nodes. Okay, so what does I have? I have node B, I have node D, I have node A, I have node C as well. Cool. Something like this over here. So now let me figure it out what, how, and that where's the edge, means from which node to which node I'm going from here based on this. Okay, so instead of this I can say, okay, as how this thing. Okay, the first we'll be looking into this ordering. That is what it says, that okay, B is pointing to A, because from the starting we can see this. Okay, B is pointing to A. Okay, B is coming before A. Okay, let me create the edge from B to A. Cool. Great. Then here's an edge between B to A. Cool. Now what I can say is that over here D is also before A. Okay, let me point that node also pointing to A. Okay, D is also pointing to A. Cool, no worries. And what I can see is that D, not D, D and B is done. Now A is pointing to C. As you can see, based on this, from this two consecutive words, A is pointing to C. Let's have an edge from A to C over here. Cool, no worries. Something like this. Great. Now, what I can say is this thing. That is, also I can see B is pointing to D. Okay, let me do that as well. From these two consecutive words I figured it out that B is pointing to D because B is before D. Great. So let's have an edge from B to D over here. Cool, something like this. Great. Now I can see that the graph will look like something like this. Great enough. Now let's consider this particular linear ordering which others have. When apple is also a word that is given to us in order to manipulate us. So here, if I can say you this thing, let me move it left side, and yeah, okay, let's say this graph. In this ordering as well, I does have node B, D, A, and C. Cool. This is also A. So what? What? from this what I can conclude, okay, how the graph should look like. Over here, B is pointing to A. B is pointing to A. Why? Because between from these two consecutive words, I figured it out. Okay, B should be before A. That is U to V. Over here, U is B and V is A. So it's pointing. Great. Now, what I can say, that also I does have an edge from D to A. Okay, let's have an edge from D to A. Okay, from there's an edge between from D to A. Great enough. Now let's have a edge from A to C. Okay, there's an edge between from A to C over here, as I can see. Cool. So now let's have a edge from B to D. Here, as you can see, from these two consecutive words, I figured out. Okay, B should be before D, and over here node U is pointing to B, and node V is pointing to D. Okay, B should point to D. Cool. Okay, B is pointing to D. Okay, no worries. But also there is one more edge. Nodes are the same, but the edges, there's one more edge. C is pointing to A based on these two consecutive words. So C, oh yeah, was pointing to C. I did that. Now C is also pointing to A. That means I need one more edge over here. Cool. So let me draw that as well. C is pointing to A. Cool. So from this, what I can conclude, that from A I can go to C, from C I can go to U. That is, the topological sort does says what, that uh, there has to be linear ordering of nodes where there's an edge between U to V, such that A has to be, oops, U has to be before V. And if there is a cycle, or there is an undirected, or both side it is directing, then there could be an difficult, I would be in a dilemma. That's an ambiguity, that how A can be before C and C can be before A at the same time. So that's why topological sorts, I could say the concept, because says that it only works in directed acyclic graph. So I need to say, okay, it should be directed acyclic graph. Is this a directed acyclic graph? No. Why? Because okay, it's a directed graph, but it's not a cyclic. I can say that it's a cycle, or I can say that it's a uh, pointing. It's a undirected. It's the behavior of this. Okay, I can also instead of this, I can also draw something like this, because it's pointing to both sides. I should not draw, but it is conveying us that it should be like this. Okay, that if this two edges is not there, then it should be like this. It will be like this edge, something like this. Oh yeah, this is that I can travel from A to C, C to A. So this violates our condition, which has been stated earlier. So it's not a directed acyclic graph property, which I can go with this. Even though there's a, it looks like a cycle over here, if it's an undirected graph. But here it's a directed graph. I can go from B to D, I can go from D to A, but I can't go from A to B. Is there's an edge bit from B to A, not A to B. That I have to consider. Over here, it's a directed acyclic graph. Okay, so means because I can write it some this graph something like this, linear ordering. Uh, up you're getting it. That what I'm trying to say. It has to be like this. Linear ordering could be drawn something like this, and not something like this. The in a linear ordering, no two letters should occur more than one. If it is occurring, that means it concludes that okay, there's a cycle. It's not possible at the same time that A can be before C and C can be before A. Over here in this case, something like this. So over here it says that D has in degree of B. A has in degree of B and D, that is it has OA has 2 in degree, D has 1 in degree, B has 1 in degree, C has 1 in degree, and this is not possible. This is possible. So this is the wrong answer. This is right answer. And if I can just simply draw this in a 0 1 format, because we decided that okay, we'll be going with 0 1 format for just for the ease of our implementation. So this graph will look something like this, because yeah, over here the only change will be this. Okay, the it will be become, it will be 0, B will be 1, C will be 2, and D will be 3. Cool. Great enough. Now, 3. Cool. So now, what I want to do. So over here, what I need to do is that firstly, I need to visualize this as a graph. So for that, I would be requiring an adjacency list. So I need to create that. Okay. So if I'll create the adjacency list of this, so I can say something like this over here. I can say the adjacency list of this is what? That 0 is pointing to what all elements? It's pointing to 2. There's an edge from 0 to 2. Now 1 is pointing to what all elements? 1 is pointing to 0 and 3. 1 is pointing to 0 and 3 over here. Now 2 is pointing to what all elements over here? So 2 is pointing to none. Now 3 is pointing to what all elements over here? 3 is pointing to 0. Okay, so I would be requiring a list of nodes to which respect to node points. That is, I want a list of this thing, that is the list of I want the additions list. So here, let's say if I'm considering this as the U and this as the V, that is U is pointing to what all elements, that is U to V. I want this adjacency list over here, that I would be requiring for initially in order to proceed further. That's the adjacency list I would be in a need of. Cool. So that is what I do want over here. And also over here I'm using I'm gonna implement this using the cons algorithm. If I'm gonna use it using the uh, DFS, then yeah, without cons topological sorting, that the recursive way I can do that. So let's say for example I'm going with the cons algorithm. So also over here I want what? I want the in degree, that which nodes I want the in degree of each node, that what's each node has miss what all nodes uh, it has coming in. So that's what I would be requiring. So here if I'll be saying that okay, n degree, I would be in a need of this as well. Okay, so the n degree would be what? Over that I'll be requiring that as well. Okay, so I know that the nodes could be from A to Z. So let's say I can, at max it will be Z only. So yeah, so that's the degree of length 26, and I would be needing what? I would be needing uh, that which node has how many n degrees. So let's say 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, and so on till 25, because there's a less, this length is 26 over here. What I want, that at each is index denotes the respective node, because node is also 0 based. So there I'll be placing the in degrees. So let's say over here for 0, what's the in degree? Is coming from 1, is coming from 3 as well. So the in degree for 0 would be 2. So what will be the in degree of 1? So there's only out degree, there's no in degree for 1. So yeah, that will be the default value, that will be 0. So what's the in degree of 2 over here? It's only 1, because it's coming from 0. So yeah, to in degree of 2 would be 1 over in this, in a case. And then what will be the in degree of 3? So there is one inward edge, one outward edge. Okay, there is only 1 degree, so 1 is pointing to 3. So yeah, for 3 node 3 also, the 1 in degree is 1. Cool. So now also I would be requiring to have the, because I need to check, because I can't have all the letters now. So I should be check that okay what all letters I does have in our dictionary, not the entire dictionary, the thing which is provided to us, that is the list of words that is provided to us. Oh yeah, as you can see that there's not all the alphabets that I does have. Oh yeah, if I'll be considering this, I does only A B C D, that's it. Okay, so what I need to do is this thing, that I need to check, I need to have a check for that as well. So let's say I'm having one more array, which denotes the existence of it, which character, and also the character that I has have max is 26 only. So let's say what will be there, I will be saying, let's say it's the boolean which denotes okay whether this nodes exist or not. So I know that 0 1 2 3 exists, so that will be true. True, that denotes that okay this character exists over here. True and true. Cool. And rest are not exist, so that the report only false over you in that case. Cool. Get. So that's the thing I have over you. So miss, I'm doing this because not all 26 characters may appear. So we track which one actually exists. That's why I'm having this thing existence or existence array, which tells me that. So now I have in degrees exist, I have the adjacency list as well. Now I'm gonna do create a graph from the provided adjacency provided adjacent words over here. So we know that how can I create this, because we went through this example and we did a dry run as well over here. So what I did over there, that I was comparing first word to the second word, means a consecutive words. So let's say this is not over here in this case in example, I just added this just to explain you this particular scenario. So let's remove this over from our example. Cool. So over here, what does I have, what I does have over here? Cool. So as you can see, two consecutive word, pair one, pair two, pair three, pair four. There is no pair for the last word. So if I can say okay, I'll be just iterating from, let's say this is the length, this is the length, and this is the second last of it. I'll be just iterating from the first till the second last. Means let's say I'm pointing to the I is equals to 0, I is equals to 1, I is equals to 2, I is equals to 3, I is equals to 4. So length is 4. So until I plus 1 is less than this length, I can go till there, I can say this thing. So I'll be having a loop of that. If I'll be writing let's say I'm writing it for Sudokuro here. If I'm writing a loop, so it will be from 0 till what, till until I plus 1 is less than the words length I does have over here in this in our case. Well, I will be running this kind of loop over here. And now what I need to check for each word, I would be checking this thing, that is need to find the first mismatch. I need to find, the moment I find the first mismatch over here, I'll be saying what, okay there is the first mismatch, that denotes that, let's say for example over here B and A first mismatch, that means this is the U, this is the V, B should come before V, that means should come before V, that is this here, U should come before V. So that means there has to be edge from U to V, that means there has to be edge from B to U, B to A, that I'll be creating. So something like this I'll be creating over here, that okay. So that means what I need to do over here, one thing, that is in this iteration I want to do, I want to build a graph from the particular provided adjacent words to me. Okay, that's what I'll be doing over here. And then I will simply go do for the entire list of words which I does have over here. And then the what I does over here means the only the first mismatch creates an edge. So the prefix case is explicitly handle. Means if something like this over here, if there is no first mismatch, in that case I'll be simply running a string that that I will be writing, that comes under this logic itself. that I'll be doing over here. And in throughout this process, I'll be having a graph. Which graph? This graph. And I'm not going to store it as the A B C D. I'm going to store it as the 0 1 2 3, something like this. So in this process, I'll be having this particular graph with me over here. So now the moment I have this graph, what I'll be doing, I will be applying Khan's algorithm in order to check whether, means what should be the ordering and whether that order is valid or not. Over there, now I'll be applying the Khan's algorithm after this. Now is the time to apply Khan's algorithm over here. Something like this. Okay. So Khan's algorithm, we already know that I need to firstly figure it out. Okay, which node has the in degree 0, get all that nodes. I need to get that all this details of it, and put that in the, or I could say offer in the queue, because it's the BFS approach. I would be requiring a queue as well, something like this. Over here I would be requiring a queue as well. Cool. Now over here, I'll be applying the cancel algorithm and find out that which all nodes has the in degree 0. So I can see that there is a node which has in degree 0, and that node is at index 1. Okay, so I'll be saying to the queue that okay, this node 1, this node 1 has in degree 0, so that should be over here. So I will be adding that over here, something like this. Okay, I'll be offering that over here 1. I will insert 1 into this queue. Cool. Now, this is the initial configuration which I'll be doing. Means here characters with 0 in degree can safely comes first. Now the thing which I'll be doing over that, I uh, will building the result using this Khan's algorithm. This was I was just doing the initial configuration over here. Now I want to build the actual result. In that result means what, that what's result means the actual ordering that I want to return. Okay, so what I'll be doing over is that I'll be iterating over this queue, whether there's an, until there's an node in this queue, while queue is not empty, I would be iterating over this. So here I'll be saying okay, if I'm encountering this node, that means the n degree has to be getting eliminated for that particular uh, edge for that particular node. Means let's say if I'm going from 1 to 3, if I'm encountering this, I'll be just simply removing that edge for the future consideration, something like this, anything over here. So over here, while q is not empty, I need to do this thing. So which node has the in degree 0, which I found from here, that is what, that is for the node z1, it has in degree 0, so that will be in the queue which I got from this. That what all nodes I has in degree 0, I'll be offering into the queue. Now I need to build a result. So what I will be doing, I'll be applying the Khan's algorithm over here. That what I'll be doing. So let's say in the iteration 1, what is there in the use, let's say 1. Now here u is 1, so it has 1 in degree has 0, so that, and it's in the queue, so that will be in the, that is the possible answer, so put it into the result. So let's have a result as well. So over here there will be this thing, that is 1 is in the result. So now I'll pop it out. Now I'm popping it out. So who are the nodes that 1 points? So 1 points to whom? So the neighbors of 1 are 0 and 3, as we can see from here. The neighbors of 1 are 0 and 3. So in this case, okay, so the in degree of 0 is what? The in degree of 0 is 2. that is no, the in degree of 0 is 2, that is coming from 1 and coming from 3 as well. And the in degree of 3 is what is 1, that is coming from 1. So I need to add this into the queue. That is what, now in the queue what I'll be inserting. And also now it is the, I'm gonna add this two nodes, that is 0 and 3 in the queue. So let me add this. So I'm adding 3 into the queue, and then I'm adding 0 as well into the queue, or something like this. So now, because now I considered 0 and 3 from the node 1, so there's no need to be having this in degree. I need to just decrement this in degree. Okay, so the in degree of 0 and 3 from node 1 has been decreased, so the in degree of 0 will be getting decreased to 1, and the in degree of 3 will also be getting decreased, something like this. Okay, so now I'll be checking while inserting that, okay, does any of this has the in degree 0? That is the potential answer, that is the answer that I need to add into the result. So I can say, okay, 3 has the in degree 0. Okay, so 3 can be in the result, something like this. I'll be just simply inserting that over here. I'll be just offering that to the queue. So I'll be adding 3 as well over here. So now it's done. So now what I'll be doing, now I'm again, okay, while queue is empty or something like this, what I'll be doing, okay, I'll be going for the another element. What's there at the peak? So at the top, what is there? At the top there is element 3, a node 3. So now who are the neighbors of 3? Okay, 3 is pointing to 0. 0. Okay, what's the in degree of it? The in degree of 0 is 1. Okay, so I'll be adding that as well into the queue. But wait, before adding it into the queue, I need to check. Okay, it's not 0, so it's not the potential answer. I'll just need to remove this edge from here. Okay, so let's do that. Removing this edge from here. Cool. Now the in degree of 0 becomes from 1 to 0, because I removed that, so it has been decremented from here. Cool. So over here in the process, I can see that, okay, the in degree of 0 becomes 0. So okay, it can be the potential answer. So I'll be adding this into the result. So here it has to be there. So I will add chem. So over here in the process, I can see that the in degree of node 0 becomes 0. So it is the potential answer. So yeah, it has to be in the result. So I added it into the result, and so now the node 3 is done. So yeah, over here it's done. So it's the process of the 3 is done. So I'll just really pop it. I need to just pop it out before this itself. So now here I just have a node 0. So node 0, or whole are the neighbors of the node 0? It is the 2. Okay, 2. Cool. So now 2 over here. Firstly, I'll just pop out this node, and now 2, I'll just decrease the in degree of 2. Okay, uh, over here, and now 1 becomes 0, because I decremented it by 1. So now I'll check, okay, whether the in degree of 2 is 0. Yes, it is 0, so it is a potential answer, so it has to be in the result. So I'll be adding 2 as well in the result, something like this over here. So 1302. So now I'll again moving, okay, while queue is not empty, I need to keep on doing these things. So over here I can see that queue is empty. So yeah, result is done. So now I need to check for this cycle. So okay, so if the in degree all of the nodes is pointing to 000, that denotes that all of the edges has been removed, that denotes that all has been processed properly. That means there is no cycle over in this case, and the final result which I got is this 1302. Now I will simply converting back into the characters, because I want that something like this. over here BDAC, something like this kind of ordering that is need. So I'll just convert this into the back to again with the characters. So this is what the uh, output which I got. So over here, what's the algorithm that we have that we built is this thing. That is in the algorithm. What I'll be doing. The step one is what? The step one is that I need to create the graph structure, and then the step two is that I need to track which characters are actually used over here. Because not all 26 letters may appear, so I mark the ones that exist. And then the step 3 which I did what is that I would be add edges using adjacent words. Because over here only the first mismatch creates a dependency. And the fourth step which I did is what is that topological sort using Khan's algorithm. I can do it using the DFS approach as well, but this is the approach which I am going with. Why? Because the zero in degree characters can safely come first over here. And then the fifth step which I did is that build the result throughout the process while the queue was not empty over in this case. Because in this process I'll just simply append characters as dependencies are resolved. And the sixth step is what? After doing all these things, I need to detect the cycles whether it is proper or not. Why? Because if anything is left unresolved, the order is invalid over in our case. So that's of no use. That doesn't make any sense to go move with that. So this is the algorithm which we built. So let's code it quickly. With this algorithm that we built, let's code it up quickly. So let's copy this algorithm so we can see that okay, this is the only approach which we are using throughout this. Okay, so let me maximize it the screen. Oh here, this is the algorithm which I have that we which we built throughout the process. So, what's the first thing that I need to do? Firstly, I would be requiring that what all miss what's the alpha value that is up to what's the possible number of alphabets that I have over here? That is the 26 over here. Now I need to create the graph. And how can I create the graph? So, firstly, I'll be requiring the adjacency list of the integer type list of integer over in this case. And let's say I'm naming it as graph, and let's say I'm using the implementation class of this as the array list. And then I need to add an empty array list for now as the initial configuration, that is and I equals to 0 until I is less than alpha is the constant which I have created. I plus plus what I'll be doing over here is in this case is this thing, that is I was saying okay for each node for now add the empty list, because for now I don't know what all nodes that it points to. So always having an empty list for now. And then I would be also requiring array of in degree for our Khan's algorithm. So over here the length of this will also be same as the alpha, because there's only the 26 characters that is possible. And also I'll be requiring an array in order to know that okay which all characters present that exist over here, because I don't need to iterate for throughout all the 26. If it is there in the worst case then it's okay, but unnecessary I won't be going with that particular way. So here the step one is what? Step one is that marking the existing character, we need to mark that. So for let's say for the each word in the words array which I does have, I would be doing what? For each word from the words array, I'll be doing what? Something like this. Okay. In this, I would be saying okay for each character, I need to convert this into character array for ease of our implementation. I need to check okay whether does this exist. I need to build the initial configuration. If it exists, okay, I need to mark it as true, because I'm gonna use the SK value. That's why I'm doing subtracting with the SK value of small a over here. And as it exists because it has been encoded, so the value of that will be stored in this particular place will be the true in this case. And also now I need to build the I have the existence configuration done. Now I need to build the edges from u to v. For that I will be iterating over the entire words that I does have over here, that is from index 0 till whatever the length of the words that is provided to us. Cool. Now what I need to see that, okay, what's the first word, that is the and the what's the adjacent word which I does have. Okay, so the words that will be at the ith index, that will be the first word, and the adjacent word will obviously be at the index I plus 1 over in a case, that is words I plus 1. Now I have to check. I don't need to the unnecessary calculation again. So I will be saying, okay, what's the length? So the minimum length between these two, till that point only I'll be just iterating. So w1 dot length and w2 dot length. These two word adders have. So which has the minimum length? Okay, that I'll be considering over here, and also and to check, okay, whether the edge found or not, in order to avoid the overhead. Initially, let's say I'm making it as false, and let's say, okay, now I'll be turning over this length which I've figured it out. Cool. So as already used, so I'll be using the j variable over here just for the simplification, just to avoid the conflicts. Okay, so now what I'll be doing is that I will be checking each character. I'll be going character by character. For w1 string, uh, what's the added particular character at index j, and same goes for the uh, w2 word as well. In that same place at index j, what character I does have, I need to find the disability. Okay, so if c1, okay, I should just simply in order to segregate it, I just need to have c1 or c2, let's say, for the ease of our implementation. So if c1 is not equals to c2, I found the disability. So this is the differentiating factor that I just have over here. Okay, if it is not equals to, so that denotes that there's an edge vector from u to v, that is from c1 to c2. So I need to create, okay, I need to get the ASCII value of it. So that's why I'm doing subtracting with the ASCII value of a. In that position I need to add what, c2 as a ASCII value. So I'll be subtracting that as well with the ASCII value of a, something like this. And then the in degree also, uh, I just need to increment at the same time in order to figure out, okay, okay, this is the character and it is the n degree of this provided character. I need to do the plus plus over here. And also I'll be saying, okay, age found, just to avoid the overhead. Cool. And if I found this thing, then there's no need to move further. I'll be simply break then and there itself. Cool. Now what I'll be doing, there could be the case of that prefix invalid which I did say to you, this thing over here, this one, this scenario, this could be the case. So I need to check that as well. So for prefix invalid case, I'll be saying, okay, if edge found is false, if edge found is false, and also the w1 length and the w2 length, if I compare this, the w1 length is greater than the w2 length, that denotes, okay, there's a prefix is the invalid. So I will just simply returning an empty string then and there itself. So now what I'll be doing over is this thing, I would be having the q data structure in order to implement the cons algorithm. So q of integer over here, let's say name it has q only, and let's say implementation class of this I'm using is the linked list over in this case. And now I need to have the variable which stores the total characters I does have. Initially, let's say is 0, and I'll be iterating over all the alpha adders have from 0 till less than alpha I plus plus. And I need to check whether if it exists, then only I'll be moving further, or else it just it doesn't make any sense. So if I'm entering over here, okay, there's one more character, so I just need to increment the total character value. And if the in degree of this is 0, if the in degree of the current character of the current node is equal to 0, okay, this is under the consideration. This should be in the queue. I'll offer this into the queue. That okay? Add this ith node also in the your queue. So now I need to build the result. So I'll be having the string builder because I need to modify it again and again. So instead of using the normal string that's immutable, so I'll be using the string builder over here because it's immutable. I can mutate it. So over here I need to initialize the string builder as well. So while queue is not empty, this is we have uh, identified an algorithm while we are solving, while we are doing the dry run. So while the queue is not empty, I need to check, okay, what all nodes I does have in the queue, okay, that has integer 0 that we inserted over here, something like this. So over here I'll pop the very first element that is at whatever that is at the peak. So q dot poll I'll be doing over here in this case. And then I will be doing, okay, this is the having integer 0, so this is the potential answer, so I'll be appending it in the order string builder. And I need to add as the, not the ASCII value, not the 01, so I want the actual character, so I'll be again typecasting it. So I need to again typecast it from the numbers which we did earlier. So I need to check for his neighbor nodes. So, what all neighbors are there for the particular v? Means what all v's are there for the particular u? So I need to get that for that particular u. What all v's are there? And also, if I'm considering this for now, so I need to make. I need to remove the degree between this. I need to remove the edge between this. That means I need to decrement the in degree of it. And if in the process the in degree of this node becomes of this node becomes 0, okay, this should be in the queue. This is the potential answer, this should be in the queue, so I'll offer this node to the queue, okay, something like this. Over here I'll offer the next node, and then I will say, okay, I offer the next node. Then I need to do the cycle detection, because yeah, in order to see whether it is valid or not. So the if order dot length, I had to check, okay, if the order dot length is not equals to total chars that I reserve over here, that says that okay, it's not the valid. So in that case I'll be returning the empty string, or else at the end just simply return the uh, string format, because I want the string forward and I use the string builder. So in this case I'll just simply run this thing, and let's compile and run it. Okay, so it has been compiled. Now see, let's try to submit it. So this is the code which we have from the algorithm which we have derived. Okay, that has been successfully submitted. So I can say that the time complexity is big of n into l, and the space complexity is constant. How? Let me tell you that. Because over here, if you can see that we scan all characters once to mark existing letters, that is big O of n into L. We compare adjacent words to build edges, that is big O of n into L. And the topological sort runs over a fixed 26 letter alphabet that is constant. So that eventually becomes, oh, the overall time complexity will be big O of n into L. And the space complexity is what the graph is there, degree array is there, queue is there, and the result store at most 26 characters. All auxiliary space is constant. That's why the overall space complexity O is the big of one, that is a constant. So oh, hey, if someone asks that why we have initialized the graph with 26 lists, then I can say that because I'm using a fixed alphabet size, initializing all adjacency lists avoids null checks and ensures every character node exists, even if it has no edges. And over here, if I can just summarize it and tell you that quickly that what we have done, that I can say that the I model the problem as a graph where characters are nodes, and by comparing adjacent words, the first mismatching character gives a directional constraint. This forms a DAG, that is directed acyclic graph, and the required alphabet order is simply a topological ordering, and hence I use the Khan's algorithm to handle cycles and ordering cleanly. So, everyone's me Deepak. See you in the next one.